Well, good afternoon, everyone, and welcome to our webinar today for top-down design. My name is Rob Romanowski. I am the Director of Sales Operations for 3HTI. And today joining me are Jonathan Conklin, who is a applications engineer from PTC, and Joe DiCarlo, one of our own sales account representatives, who has had a lot of experience with his customers with the advanced assembly extension. And basically what this does is it allows you to, if anybody who's making a product with a model with more than one part can have advanced content with better control and get more customized designs a heck of a lot faster using the advanced assembly extension. One other thing to just point out is that PTC is offering as an incentive this month that when you purchase a new subscription of Creo, you will receive extensions at 50% off. So the advanced assembly extension would be 50% of the normal subscription price, and that's not just for the first year. That price is protected ongoing as long as you continue to use the software. So with that, I'm going to let Jonathan take it away.
All right, thanks, Rob. Like Rob said, my name is Jonathan Conklin. I'm here with PTC out of the Virtual Center of Excellence. And what I want to do for you guys today is just step you through the Advanced Assembly Extension. We'll go through why you need it, what some of the challenges are that people are facing prior to using this extension. Then I'll introduce the software. We'll say what it does. I'll show you all the capabilities. And then we'll jump into the actual software. I'll give you a brief demonstration of how multiple engineers can concurrently work on a large assembly in a very efficient manner. And again, if you guys have any questions, we have a chat box that we can answer your questions through, or we'll read them off of there at the end. And that sounds pretty good. So let's go ahead and get started. And like I said, the topic today is the Advanced Assembly Extension. So, oh boy, we are frozen. One moment, please.
No worries, Jonathan.
That's Friday for you. We may have to improvise here. Give me one moment.
Sure.
It's all that snow and cold weather.
That's what it is. All right. Let's see. I'm going to pause my screen for one moment.
Two of the things that we're going to show within this overview. One of the things with top-down design is being able to build off of a skeleton model, and that's going to give you more of a capability to have a better parent-child relationships within the model itself, as well as being able to work collaboratively. Having other people be able to have access and work on these designs and also know who's doing what. So Jonathan, are you ready?
Yeah, that's exactly right, Rob. And yeah, it looks like we're good to go. So let's jump right into it. So again, the name of the game is the Advanced Assembly Extension. This is all about building concurrently with all of your design engineer teams on large assemblies. So, I mean, if you're thinking about designing something and it's relatively small, such as 10 to 20 parts, it's pretty easy to assemble. Having design intent, it's, of course, very important. But when you're doing it on that scale, people tend to say, well, it doesn't really matter. It's only a couple parts. We're going to throw it together. And if we have to make changes later, then we'll deal with the headache then. And that's usually not a problem. But what happens when it's a bit bigger? What if you up the ante to, say, 200 parts? Okay, so then you try to put it all together without that design intent, and your boss says, hey, we're going to make a change. Well, then your life becomes a little bit harder. You say, okay, well, because we didn't have that design intent put in place, now we have to work extra hard to make all of this work and come together. But maybe you can still do it. Let's jump it up another ante. Let's say you're working for a large corporation, or you have a large contract and you have large assemblies, 20,000 parts. If you don't have that design intent in place, that's basically a death wish. Trying to make changes is going to be incredibly difficult. And we've seen that time and time again with customers who come to us and they say, we have these large assemblies and our guys, it's a disparate team and we don't really have the design intent put in place. How do we make this work? So with these large assemblies, of course, there's another aspect to it too, right? When you try to load them in, depending on your hardware situation, they could be slow to retrieve and slow to work with. And also, if you're working with a global team, or you just have teams that are in different places, it's hard to collaborate with them with these large assemblies. So you need tools and a formal methodology for top-down design specifically, so that you can have these tools in place so you're not running into the issues that I just talked about, and so that you can streamline your process. And of course, we all know that changes can be costly and time-consuming, and you don't want to have those roadblocks in place to inhibit you from getting your products out to market faster. And let's take one more look at this. So maybe you have a bunch of designs or a product that just has slight variations to it, and you just want to swap things in and out. Design intent is important there too, because you want to have the ability to easily swap parts in and out without having the headache of setting up an entirely new assembly and starting from scratch just for a simple swap. And then again, maybe you're working with contractors and you're worried about your intellectual property. You want to be able to collaborate with these vendors without compromising your IP, but still giving them enough information that they can work off that model and complete the tasks with what they need to do. We need to do this faster. That's the bottom line. Time is money, and we want to get these out to the market faster, and we also want to have everything run smoothly and efficiently. So that's where the advanced assembly extension comes into play. And like Rob was saying, this is something that's great for large assemblies, and this works off of skeleton models, which enables you to do things much more efficiently and work with disparate teams or teams that are all over the world, and just makes for a more cohesive manner in doing these types of things. So let's walk into the capabilities and see what all this means. So again, this gives you a formal methodology on design intent. So what we like to do is we like to call this the top-down design approach, right? Where it's built down in a top-down manner so that everything is associated to each other, so that whenever you have a design change that comes down the pipeline, you're already prepared for it. So you're not scrambling and you're not doing things from scratch again. So this is really great for part placement, geometry sharing. Again, think about that swap scenario. Maybe I have a tank that I'm building and I want to be able to switch out a door or something like that. Instead of recreating the model, we already have that design intent in place. We can simply swap the necessary components because we have that geometry sharing put in place, and we're good to go. Same thing with mechanism design, right? Say you are working on a mechanism and you have all that design intent in place, but you want to try out another tool head or something like that. This is perfect for it, where you can instantly swap in and out different components, but that same design intent is going to be still in place, where you have that formal general idea of where your mechanism is going, and it's following that path. So these all work off the skeleton model, and a skeleton model is a special type of model that resides at the top of your model tree. And basically what this does is it houses all of the design intent within this part file. So it contains all the key design information about location and interfaces between all the different geometries and features and parts. And it's always going to be first within the component list within your model tree. And an important thing to remember with this is all it's doing is holding all that key design information. So it's not going to show up in any of your bill of materials, in your mass properties, or if you're doing any type of simulations. No, it's not going to show up there. It's just basically a framework situation that's housing all that information. So that's important to note. And I'll go into that in more detail within the demonstration as well. Another thing that you get with the Advanced Assembly extension is a reference control. And this is where you're going to manage and limit all of your component resources. And there's a couple ways to do this. So whenever you create a reference, of course, there's going to be relationships with each of the different parts. So you're going to have this parent-child relationship. So this gives you a view into how those relationships work and how they impact each other. And so with this reference viewer, you can go in and take a look at those relationships and see what kind of references you have, what kind of dependencies you have. You can change the scope from a sub-assembly to the entire assembly. You can see whether they're strong and relationships with these references. You can even take a look at the reference types. And all of this can be controlled and monitored from the engineer's perspective so they know exactly what's happening with their large assemblies. You can also work with inheritance models, which are basically one-way associativity. So if you're working off a model or you have a product that is very similar in nature and you just want to add on to it a little bit step by step, you can inherit that, that information from previous models and incorporate that into your new design very easily without impacting the ones that are upstream. We also have interchange groups, something that I've been harping on quite a bit, so that you can instantly swap out different components without having to redesign things from scratch, making it much more fluid, much more streamlined for the engineers to swap out parts for what-if scenarios or for maybe even completely new products. It really just enhances the experience and gets things streamlined. You can also do merge and cutout much easier. So you take your block, you take your cutout and you merge the two, and then you can get the positive and negative space very easily with this. So the value from this is ultimately, I'm sure you guys can see this as well, is it's going to improve your performance. It makes working with large assemblies much easier and working with different engineers concurrently much more efficiently or much more efficient. So you're using less time dealing with the models, and you're spending more time designing, which you should be doing. And you're making these changes with confidence. You're not worrying about, okay, is this going to wreck the model? Do I have to start this from scratch? Or what is this going to look like? No, you already have the details in place with the design intent. Just make the change, see if it looks good, and then make the necessary changes that you need to. So you're designing with confidence, and that's the most important part. And it enables you to have efficient reuse of your models. So you're not just designing them in a one and done scenario. No, use them over and over again. Use them in different products in different scenarios and have that confidence in place that they're all going to work out. And again, this now enables you to work collaboratively, both internally and externally with a multitude of partners. It also enables you to protect your IP when you're sharing it out to different people. And that's all thanks to the skeleton models. And again, I'll show you that within a demonstration so that I can make that more clear for you. Speaking of the demonstration, let's actually just jump right in. And so what I'm going to show you here is a large assembly of a train. And this train is going to be worked on by 4 different engineers. They're going to have 4 separate tasks. Some of them are going to be working on the internals. Some of them are going to be working on the clearances for the windows. Some of them are going to be working on the interior design. And we're going to show how they can work all collaboratively and concurrently on the same model by using the skeleton models, and how all of that can come in and merge together on the final design. So without further ado, let's get that up and running, and I'll show you what that looks like. So here we have our file, and again, this is a large assembly. We're going to be working off this train, and even from this, you could see we have a lot of sub-assemblies that make up this specific assembly. So what I want to do is first create a skeleton model so I can share it out to my engineering team so that they can work on different parts of this model concurrently with just the geometry information that's important to them. So let me show you what I mean by that. So what I'm first going to do is start publishing specific geometry so that I can share it out to specific engineers. So I'm going to grab things that are important for their specific scenario. So remember when I was saying some engineers are going to be working on the internals, some of them are going to be working on floor placement, some of them are going to be working on windows, things like that. This is how we're going to reference all of those different surfaces and pass that information on to those engineers so that they can work on it. So what I'm doing is I'm publishing those geometries. I'm just grabbing the information that they're going to need. Things like the floor placement, the real estate that the door is going to take up. Same thing with the windows, grabbing that. So that's one publish. Now I'm going to do a separate publish for another engineer. And maybe I'll grab, again, the outside of the quilt for our train. And maybe I'll, again, grab some windows, I'll grab some door frames, things like that. And I'll give that a name. So this will be for the engineer who's specifically working on the interior. And all of these are going to be housed within my model tree as well. As you can see, there's our skeleton model, like I said, residing on the top. And I'm going to grab that structure in that interior that I just published, and I'm going to copy that geometry to this pertaining skeleton file or skeleton model. So now when I activate that and I copy that geometry, whenever somebody opens that specific file, they're only going to see that geometry. So here's what I mean by that. We now have 4 engineers working concurrently on just the geometry that I publish over to their specific skeleton file. So now they can make their necessary changes without having to load in the entire model, wasting time with that. Or let's say I have some of these engineers aren't even internal, right? Some of them are from different companies, and I don't want them to know my IP. So I just send them what they need, and they go and design their specific function. So I got one guy working on the wheels. I got one guy working on the internals of, the door placements. Some guys working on the seat placement, things like that. And the cool thing about this is whenever these are updated and sent back to me, they're all going to be incorporated back into that large assembly. So I have no loss in workflow. So I don't have to manually go in and check their piece and go, okay, is this going to work? Or I don't have to spend time designing it myself. No, I just have them all merge into the large assembly, and then I'm good to go. And since we have that design intent in place, I know that their specific jobs, whatever they do, is going to work in the context of what I need it to do. And if it doesn't, I can easily go in, and the system is going to flag it and say, you have an interference here. So I know for sure that I have quality control on my large assembly, so I can get these out to market much faster. So let me show you what I mean. Let's say some engineer is doing some funny stuff, and he creates something that's out of bounds of what he's supposed to be working on. Like he creates the chair here, but unfortunately he didn't create the correct clearance. Let's see how that works in the context of our large assembly. So if we do a section view here, you can actually see that we're going to have an interference, and that's denoted in red. Right, so that's obviously going to be a problem for us. But by using the techniques that I talked about with the advanced assembly extension, that's not going to be an issue for us. We just redefine what that distance is, what it's supposed to be, within the references that we put in within our model, and we make the change. So we go into our seat, we activate it, go into that specific sketch that the engineer put in place, and we put in the appropriate value. Now we have something that's workable. We no longer have that interference, and we can pattern out all of these guys to create the entire interior for the train. And again, since we put that design intent in place, we know it's going to fit within that envelope because we designated, the specific envelope within the skeleton model, and we can design with confidence and get this done much quicker. So now I'm going to check this back in, and when it's checked back in, the main engineer is going to take that large assembly, regenerate it, and he's going to see all of these changes put into place. So now I can work with multiple engineers from multiple different locations on one model and have this come together very seamlessly and very effectively, and I can get this out to market faster. So that's basically what the advanced assembly extension is in a nutshell. I'm going to pass this back over to you, Rob, and if we have any questions, we'll answer them as they come in.
Sounds good. Nice job, Jonathan. Yeah, like I said in the email invitation, and first thing I did was I made a mistake in the text portion. I had it say how to running a top-down design process, because I had a couple of thoughts as far as the title was concerned, and I just wanted to call it how to run a top-down design process. But anyway, if there's anything, any questions you have, type them into the dashboard. If you think of something later, just feel free to reach out to us and contact us. You can email us at info@3hti.com. My email address and direct line are here in case you want to contact me. If you want to do a more detailed demonstration we can do that for you, something that's more in depth. But basically today we just wanted to give you an overview of the Advanced Assembly extension. This is one of the, I think, more productive extensions from a general standpoint that PTC has, as opposed to some of the more specific ones that can really, help most Creo users and CAD users be more productive. Joe DiCarlo, is there anything you want to add before we are dismissed, because we don't have any questions at this time?
Yeah, Rob, I'll just add one or two more things. So although you saw most of the demonstration in the context of an engineering design, you can start to think out of the box a little bit with what you can do with Advanced Assembly extension. So one thing Jonathan mentioned was an inheritance model. Think of when you're in engineering and now down in manufacturing, they might have to use your model. They might have to add some features that will allow them to manufacture the part more easily, but they don't want to change the original design model. It's a perfect application for an inheritance model where they can inherit the original design geometry, but then add or put features on that they may need for manufacturing. Second feature that a lot of my customers have found useful inside of Advanced Assembly extension is something called copy geom. And this allows you to start a new part based on surfaces or geometry from an existing part. So think of a flange where there's a mating housing that has a bolt hole pattern with a bolt, washers, and nuts that hold it together. Well, for the housing, you can actually use the flange geometry as your starting point. What this gives you is associativity between the two parts. So if the bolt hole circle changes or you need to change the number of bolts, all of that will update automatically on both parts, and that flows down to your bill of materials. So now no more miscounting parts or not having the right amount of parts in the bill of materials based on the assembly that you're creating, because now all of that is linked together in one associative model. That's it, Rob. I just want to point out those couple things because, I found a lot of my customers find that useful. It's not readily pointed out in the demonstration.
They're good points, Joe. Excellent. Question that came in: does one person or company need to maintain the master assembly?
Yeah, so I mean, someone is going to need to maintain that master assembly, and you're going to check that into your PDS system like you normally would. You saw within the demonstration, when I shared that out to the multiple engineers, one thing that they did at the end was they checked back in their specific model. So when they check that back into their PDS system, that's going to go ahead and incorporate the changes back into the large assembly, which is going to be residing within your PDS. So you would have someone denoted, maybe the main engineer, who's going to take care of that main assembly. When they open that back up, since everything was checked back in, those changes are going to be readily available when they regenerate.
What might be a solution? Next question. What might be a solution to working with different companies to keep their assemblies on different servers?
That is an interesting question, not something that I know readily available. If that's of an issue for you, that's a main concern, maybe we can take this offline and look at some solutions.
Joe, is there anything that, with as far as wind chill is concerned, that could help with that? It sounds to me like they're working with several different companies, and they want to keep all that information and that intellectual property per customer partner separate.
Yeah, I think to Jonathan's point, Rob, we need a little bit more details on actually, how this is structured. I mean, are these suppliers and the customer is getting the information from the suppliers, but then they to maintain that in one assembly? That might be a need for Unite technology where you can use parts from different CAD systems or the same CAD system inside of Creo, not recreate that geometry, have it in as a reference assembly, but then also have, your native geometry in the same file session. I just don't know if there's a way that you need to link up with those servers, or with these customers just pass the information to you and you maintain it on your site. So Well, like I said, we'd have to do a little bit more investigation, I think, to give a accurate answer.
I think that makes sense. Excellent. So once again, I want to thank everybody for being on. Thank you for the questions, and we're within a half an hour. We don't want to, take up everybody's time because everybody has a lot. There's a lot going on, I know, with our company, and I'm sure that everybody on the line today has a busy day ahead of them. So once again, thank you for being on. If you need anything, please feel free to reach out to us, and have an awesome weekend. Thanks, everybody. Thank you, Jonathan, and thank you, Joe. Take care, everyone.
Take care, Rob, and take care, everybody else on the line.
Take care. Bye.